Good evening, sir. Our project is elderly patient monitoring based on GAIT analysis. Our team number is 41 and team members are Vigneshwari, Vimala and S. Prasanna, which is supervised by Mr. M. Ramesh. The main objective of our project is to outfit the elderly patient with wireless and wearable vital signs and then collect the detailed real-time data on physiological status of the elderly patient. If any abnormal situation arises, the collected real-time data will be passed to the closer one by means of GSM modem. In existing method, the real-time data based on the patient will be a camera-based one. The cost of effective of the total project will be very high because we did not place the cameras on anywhere where the patient is located. So in our project, we use the wearable low power sensor, which is a very low power and very less cost. By using wearable low power sensor, we measure all the parameters related to the patient health for the analysis of a project. And the real-time data will be collected by means of a microcontroller. If any abnormal situation arises, the alarm will be raised and message will be sent to the closer one to the patient. This is a block diagram of our patient project. In this model, we have three types of sensor: temperature sensor, heartbeat sensor, and oximeter sensor, which is connected to the patient body by means of a strap. For each sensor, we set a threshold voltage, and from each sensor, we provide an analog output, which is connected to the digital by means of ADC pins of an X-Mega microcontroller A3BU. The microcontroller is powered by means of power supply. For each sensor, we set a one threshold voltage. If we exceed the threshold voltage, the alarm will be raised and the message will be passed by means of a GSM modem, and also the alarm will be raised where the patient is located in a particular room. Keyboard and display interface is used for programming and also for set the threshold value. First model is a temperature sensor model. LM35 is used for the temperature. It's mainly used for measuring the temperature sensor. In our project, we measure the body temperature by using the sensor. Its operating voltage is 4 to 30 volts, and its output is in the range of 0 to 5 volt. The main advantage of this LM35 is it directly gives a Celsius value without we going for convert the Fahrenheit value. It is mainly suitable for remote applications. Based upon the sensitivity, we done the code for the temperature sensor. For 1 degree variation, it provides an output of 10 millivolt. So based upon the sensitivity, we calculate the quantization step size. The quantization step size is equal to 1000 millivolt divided by 4096. The 1000 millivolt is the reference voltage of ADC pin, and in X-Mega microcontroller, the ADC pin is of 12-bit resolution. So 2 power 12, which is equal to 4096. So 1000 millivolt divided by 4096, which is equal to 0.24 millivolt. In temperature sensor, we get an analog output. By using ADC pin, we converted into digital. The digital value into 0.24 millivolt, which is quantization step size, which is equal to we get a Celsius value. So this is a table we use for the calculation for Celsius digital voltage into Celsius. If the digital voltage is 1024 means we get a 25 degrees Celsius, and if the digital voltage is 2047 means we get a 50 degrees Celsius, and if the digital voltage is 4096 means we get a 100 degrees Celsius. First model is a temperature sensor model. This is a program we done in a temperature sensor model. First we built the code, go to build and build solution. The program is running and check the error. First, we done the temperature sensor model. This is the coding for temperature sensor. We done it. First, go to build, then click the build solution. We get a build to succeed, which means that there is no error. And then go to debug start, debug and break. Give a start, debug and break. The code is running and then we get a stop. After that, we play the stop button. In the microcontroller kit, which is displayed in temperature which is equal to 36 degrees Celsius. This is the connection we did it. In the code, we perform sample is greater than 38. In the LCD display, we give the temperature sensor is 36, so the alarm will not be raised. If we change it, based upon the requirements, we set the threshold voltage. The program is running and then the program is stopped. Then we continue this code. We set a threshold is 30. Above the threshold, the buzzer will be raised. And also the message will be sent by the GS. The next model is a heartbeat sensor. The normal heartbeat range of a healthy patient is between 80 to 120 millimeters of mercury. The heartbeat sensor is operated to 20 to 5 volt, and the output is in the data level of 5 volt TTL level. Its sensitivity for 1 beats per minute, it gives a sensitivity of 250 millivolt. The heartbeat detection is indicated by the LED, which is 60 nanometer, and output high pulse is indicated by means of that LED also. So this is the heartbeat sensor we use, which is a three pin sensor. First pin is VCC, and second is data, and third one is a ground. In the data pin, we connect the J3 header of port B. J3 header of port B. This is the heartbeat sensor coding. First, similar to the temperature, first we built the coding program. Have 0 error and there is 1 warning. The warning is not a problem at all. Then we give a start, debug and break. We get a stop command. Then click the continue button to continue the program. This is the heartbeat sensor connection. If you connect it, we get an indication as light is glow on. By using this, the sensor is powered up. If you're not touching the sensor, we get a 0 BPM in the LCD display. If you touch the sensor, now I am touching the sensor. I am set the threshold voltage as sample is greater than 95. I am setting 95 is a threshold. If we exceed the threshold voltage, the alarm will be raised. For example, I am touching the sensor. In this we get a 98 BPM, and now we hear the alarm will be raised. The normal for a normal patient, the heartbeat is between 70. The next model is the accelerometer sensor model. The main use of accelerometer sensor is to measure the movement of the patient. The supply voltage of accelerometer is 1.8 to 3.6. We use the accelerometer sensor in the model of ADXL335. These accelerometer sensor has three outputs for X, Y, Z axis. From each axis, we provide an analog output. The produced analog output voltage is proportional to the acceleration on the specific axis. The sensitivity of these accelerometer sensor is 300 mV per gravity. Based upon this sensitivity, we do the coding for the accelerometer sensor, and this is the accelerometer sensor we use, and this is the ST pin, and Z, Y, and X, and VCC. ST is the select test pin, and these three axes we provide an output, and VCC is used to power the sensor. This is the accelerometer analog output. We perform the we take only the analog output for the accelerometer sensor. We did the coding, but it is not a completely one. So we do only the analog output taken, and this is the vertical position where the accelerometer is sensed, and this is a place where the accelerometer is placed. In various position, for each position we get a individual analog output voltage. In vertical position, for Z axis we get an analog output of 2.56, and in horizontal position we get an analog output of 2.39. In various position we get various analog outputs. Mainly the maximum duration occurs in the Z axis, so we concentrate only on the Z axis for measuring the movement of the patient. From the each sensor output, the message will be passed by means of GSM modem. The main use of GSM modem is used for transmitting the message to a mobile node. It gives a supply voltage of 12 volt DC, and its operating frequency is 900 to 1800 megahertz. By using this modem, we can make audio calls, SMS, and attending the incoming calls with a simple add command. We use putty software by use of this message into the closer one to the patient, and the transfer distance is of 35 km. The simple add command is used to transmit the message. This is the add command AT plus CNGF gives the SMS message format, and if we send it, we get out OK as a confirm one, and then we send AT plus CNGS. In this we give a mobile number where the message will be sent to the patient. That mobile number is given to this command. By using this command and give a mobile number, then click then do running, we get an OK as output. Then the required message is sent to the closer one to the patient. By using putting software, we have a terminal like this. We set a COM port 3 and baud rate of 8-bit, and parity is none. By using this, we use simple add command plus first AT plus CNG is equal to 1, then give a OK, then give AT plus CNG is equal to where we send the mobile, and which number we send the mobile we send the message. That number is given to this place, and then test, which is OK. Then by using this command, we get a message, and the message will be sent to the closer one to the patient as the patient is located. This is the transmitting message. First check the heartbeat and the temperature, and then they give the temperature is 32 degrees Celsius and the beats is 70 BPM for the temperature and the heartbeat, and we are not doing the accelerometer sensor. And finally we provide a send message like this format. Thank you.